Hello, welcome to part 10 of how to make Really Garden in Roblox. In this video, we're going to be adding mutations, and there's a bug where when you rejoin, the fruit on trees won't grow again. Now, I'm not actually going to fix that in this video because it's kind of a difficult fix. I rewrite quite a bit, but this video is already a bit late, so I need to get it out. I'll do that in the next one. The first thing we're going to do is make a module called mutations. So right here in server storage and modules, add a module script, and name mine mutations, and then of course change this. And then inside of this table, I'm going to add my mutations. So I'm going to add a golden mutation, golden, and it equals a table. And inside of this table, we're going to add the name, the chance, and this is in percentage, so I'm gonna make it 5%. Actually, I'm gonna make it 50% for testing. I'm going to add the price multiplier, so price multi. This is gonna make it 20 times as much, so it'll be worth 20 times as much if it's golden. I'm going to set exclusive to false. So exclusive is like if you want it to be exclusive. So you want it to be like the only mutation. So if this one's active, no other ones are, or if other ones are active, this one can't be. So I'm gonna turn that to false. I don't think any of mine are actually gonna be that right now, maybe in the future. Growth mutation. This is true for the gold one, and other ones like it. It's just something from Gorilla Garden. I'm not even really sure exactly why. Well, I do know why. It's because it's a growth mutation, so it's like got a different model. And then when we calculate it, we'll use that and then a summation of the other ones minus the number of mutations. And then has model equals true. Now for these, I might actually end up making it so that instead of having their own models for them, they just have like different reskins. And if you want to make them look different too, that'll be cool. So now that's it for that one. I'm going to show you how to make other ones though, like rainbow. So if I wanted rainbow, I'm gonna copy paste this, but I'm gonna make it 25% chance. I'm gonna call it rainbow. I'm gonna make it 50% or 50 times multiplier, 50x. Exclusive is false. Growth mutation is true. Has model is gonna be true. And lesser mutations, this is gonna equal a table. Should have put that comma. And in this table, I'm going to put the names of other ones that are not as good, like golden. So for mine, rainbow is going to be basically a higher tier of golden. So you can't have golden and rainbow, right? I'm basically making it so if it has model, it can't have another one that has model, because that wouldn't make sense. I think this is a growth mutation. You can only have one growth mutation, right? So I put in lesser mutations, so it knows which one to prioritize. So if you get this one and golden, it'll keep this one because it's better. Let's see. Oh yeah, I'm gonna add a giant mutation. So giant equals table, name equals giant, chance equals, let's do 40% just for now. Price, or no, not price multi, size multi equals, I'll do 3, so it makes it 3 times as big. And you don't really need it to be random. I can make it like that in a different video if you want it to be, but since the other things are random, if it's between, because you know plant scale or whatever, let's say you have it between 0.8 and 1.2, then if it's 0.8 and you multiply it by 3, you're getting 2.4, and if it's 1.2, you're getting like 3.6. That's a pretty big difference. So I think it's okay like this. So size multi, and then exclusive equals false. Growth mutation equals false. Right, wait, no. Is that one? No, that's false, because it can be golden and giant. So actually, you don't even have to add growth mutation into these ones if you don't want, the ones that aren't growth mutations. But I'm going to, just for clarity. Now, you need to make sure has model is false. And also, actually, I think you can leave that out too. But I'm putting them all in all of them, just changing the values so it's better. Except for size multi, that doesn't go on those ones. I'm gonna make it 2 times as much money as well. That's pretty much it. Those are examples. So we're just doing percentage-based mutations right now. The ones that you get from like weather events and things, I'll do those after we add events, which will be sometime in the future. Not really sure when. That's it for our mutations module. Now inside of plant handler, we need to change the determine mutation function, because right now it just returns normal and it's not ideal. So I'm going to get the mutations module first. So local mutations module equals require require server module, server storage. Oh, I need to make a server modules folder. So local server modules equals server storage dot modules, and then server modules dot mutations module right there, and then local mutations list equals mutations module. And now I'm gonna sort it based on chance. That way we get the rare ones first, I believe. So, or last. I don't know, one of the two. So I'm just going to say, or put in a table dot sort mutations list function a comma b, and local a chance equals a dot chance, local b chance equals b dot chance, return a chance greater than b chance. And then down here, local chosen mutations, I'm gonna make it table for mutation name, comma mutation in pairs, mutations list do. Whoops. Oh. Do. I'm gonna make a random number for a percentage basically. But I'm gonna do between 1 and 10,000 so I can have decimal places. So local random number equals math.random 1, 10,000. So I could do 1 in 100, right? And then it'd be a specific percentage. And we're gonna do like if it's less than a percentage, but then you can't have any decimals. They have to be whole numbers. If I do 1,000, you can have 1 decimal place. If I do 10,000, I can have 2. So I can have 0.01 is the lowest I can have, which I would like. You can add more zeros if you want lower. You're just gonna have to change the amount we multiply by. So since we're adding 2 zeros to that 100 to make it 10,000, then I have just in the if statement I have to multiply by 100. So if random number is less than or equal to mutation.chance times 100. See, because 2 zeros are added here, 2 zeros are added here, so it's times 1 is the same. Add the 2 zeros, just like we add 2 zeros here. So if you add another 0 here, you have to add another 1 here. Now, we're going to add a then, because, that means it was chosen. So, but now we have to check some things. Local is chosen equals false. If mutation dot exclusive and number of chosen mutations equals 0, then is chosen equals true. Else if not mutation dot exclusive, then is chosen equals true. That's basically just so that if it's exclusive and there's already one in there, it doesn't choose it. If is chosen, then table dot insert chosen mutations, mutation, if mutation dot lesser mutations, then for underscore comma mutation and pairs comma lesser mutation in pairs mutation dot lesser mutations do if chosen mutations lesser mutation, then table dot remove chosen mutations, table dot find chosen mutations comma lesser mutation, and down here if mutation dot exclusive, then break. Basically, so we don't get any more added because it's exclusive, so we don't want any more. Also, delete this, return normal. I should have done that at the beginning. Oops. Now we need to return chosen mutations. That should be that function done. So now, inside of initialize plant, when we get the mutation. Equal mutations. Then in here, we need a few things changed. In initialize plant, right here, I'm going to put in a new variable called model mutation. So local model mutation equals normal. And then I'm going to copy model mutation and do if plant folder find child model mutation and switch this one as well. Then down here, we're going to get rid of the set attribute mutation. We're going to keep the other one though. Now we're going to calculate some multipliers and things. So local growth mutation price multi equals 1. Local mutation price multi equals 1. And local number of mutations equals 0. Local size multi equals 1. For underscore comma mutation in pairs mutations do if mutation dot has model, then model mutation equals mutation dot name. If mutation dot price multi, then if mutation dot growth mutation, then growth mutation price multi equals mutation dot price multi. Else mutation mutation price multi plus equals mutation dot price multi. And now we're also going to add to the number of mutations. Number mutations plus equals 1. Don't do it in the growth mutation one because that's separate. We want to know the number of mutations right here so we can do it, because on the wiki it actually tells me for the Gorilla Garden how they calculate their mutation prices, and we're just going to do it the same way. If mutation dot size multi, then size multi plus equals mutation dot size multi. Cool. So now down below we're going to calculate out the price multiplier. So local price multi calculation is not too bad. So it equals growth mutation price multi times parentheses mutation price multi minus number of mutations. That should be it. So now plant scale times equals size multi, price times equals price multi. Oh, whoops, right here where it says this, do if model mutation and all of that, and else return nil. But yeah. Yep. So then we've got all the rest should be good. I guess I'm gonna bring in some of my models for I made some plant models, just reskins for the multipliers. So now, basically, I have these in my apple tree. That's the only one I'm doing right now. So the other ones are just gonna not get mutations, I guess, except for the giant mutation, because that one doesn't require a model. So now, we're gonna have to change some things in the plot data handover. Actually, and in the load plant. So let's do that. I believe it's gonna be in serialized plot first. Serialized plot. Oh wait, plant info. I think this is going to change a little bit. Yeah. Okay, so get rid of this mutation. Instead, down here, we're gonna do mutations. It's gonna equal colon table, and then model mutation string. Now, inside of serialized plot, we need to get the mutations. Actually, no, also in plant handler, the actual plant thing. So I need to change a little. And also, I believe I found a bug, which I forgot to get rid of. Well, actually, no, things are saving fine. Yeah, okay, so in plant handler, up here, in plant type plant, Down here, I'm going to add mutations. It's going to be a table and model mutation, which is string. And then now I just need to set those. We're going to do that in just a moment. Let's do harvest plant first, actually. Inside of harvest plant, right here, right before we make the new plant item and everything, and right after we need to get the plant info. Local plant info, colon plant, equals plant handler, dot plants, plant. We're going to say local mutation string, equals nil. Mutation string, mutation string, local number of mutations in string equals 0. If plant info, then local mutations equals plant info dot mutations. We're going to set that a little bit. If mutations, then for I equals 1, comma, number of mutations, do I equals 1, then number of mutations in string plus equals 1, and mutation string equals mutations I name, else number of mutations in string plus equals 1. Mutation string equals mutation string dot, well, this right here, mutations I dot name, and I believe that is everything inside of that if statement. And then, where is it? Local tool name equals, and then I just copy paste this right here, and then actually right here it's going to be tool name. And then if mutation string, then tool name equals tool name dot mutation string. Oh, that's why I forgot right here. This right here, dot that. Cool. So we got that right there where it opens up like that. And then we need it like this, and we dot a comma space, and then we dot this. And now right here we say if that, then we're going to say mutation string equals mutation string dot closing bracket. So it's all in brackets like that. Should look pretty good. Oh no, that's what it was. I'm just going to this right here. So tool name just equals tool name dot these brackets, and I get rid of this right here. So I keep this comma because we wanted to do that. Okay, that should be good. Now what we need to do is check for next we're going to do the load plot function since we have changed a little bit. Load plant, sorry. So we add mutations and model mutation, and then we're basically going to copy this from initialize plants. This right here, this whole section right here, I believe, yeah. So from the growth mutation price multi all the way down to price times equals price of multi, we copy that, and then right in here, I paste that in, and that should work just fine. The next thing we're going to do is, oh yeah, by the way, for your mutation module or models in like here, you know how in normal the final stage has an ID? Well, in the other ones you don't want that. So I think I actually have one in this one. Yeah, no, delete it if you have one. Get rid of the ID. Cool. So now we have to change a couple of things in here. See, no, we're getting rid of that. So we don't have mutation, right? So it's gonna get mad at us. So if model mutation and plant folder, go and find first child model mutation, then change this to model mutation. Then right here we got else. So at first it's gonna be else if not model mutation and plant folder, colon find first child normal. Then plant folder equals plant folder, colon find first child normal. Then everything else should be just fine, except for the this right here, get rid of set attribute right there for the mutation. And inside of plant table, we need to get rid of, okay, there's no mutation. We need to add in mutation. So just mutations equals mutations, model mutation equals model mutation, and then same with initialize plant down here, all the way down when we make the table. We need to set mutation and model mutations. So mutations equals mutations, and model mutation equals model mutation. And then that should be most of it. We didn't do everything in plot data handler yet though. That's most of it though. So now over in plot data handler again, we did the serialized plot part, right? No, we did not. See, get rid of this mutation thing right there. Yeah, so inside of serialized plot, before these, we're gonna say local mutations and local model mutation. Then here, mutations equals plant handler dot plants plant dot mutations, and copy the exact same thing. Do model mutation. Do model mutation. Now we're just going to add mutations equals mutations and model mutation equals model mutation. That should be it for serialized plot. Now in save plot, I believe, yeah, save plot should need to be changed. Load plot will though. So right here in success and data inside of there, we are going to be getting the attribute, all of this, plantinfo.mutation. No, plantinfo.model mutation is what we're looking for now. If new plant, then, and don't forget we need to pass through the mutations. Oh, which we don't have, because we need plantinfo.mutations and then plantinfo.model mutation. And if we just put those through, should work. Do not set attribute mutation. Everything else should be fine though. Let's test it out, I guess. Oh, which one received an error? Plant handler or experienced error. Mutations. What do you mean mutations is not? What? Oh, that's supposed to be in here. Sorry, I accidentally got it messed up. Now if we play it, should. Oh, okay, yeah, let me reset the data, because it's trying to load in plants, and it's gonna be broken. Gonna reset the plot data. Now if I plant an apple. Oh, it got giant and rainbow, which rainbow I literally just randomly spammed different colors on different parts. Okay, so that's not bad, that's not bad. Attempted to index nil with config. Oh, because I imported these from a different game and I didn't reset the fruit value properly. So inside of apple tree, inside of all of these, like inside of rainbow fruit folder, I just need to set it to this. So you should already have that done, since you're not doing it in like 2 separate games, probably. Okay, so we got that. Is it gonna get a mutation? Yeah, giant mutation. Why is it getting the rainbow mutation so much? Anyways, and then see, the apples are normal sized, which I don't know if that's how they're supposed to be. I don't play Growy Garden a lot. You'll have to let me know, because if they're supposed to be big too, I'll make it that way. I still have to fix that bug too. Oh yeah, here's a giant apple too. And let's see, now how much is it worth? That's a big question. 46. That's a lot more than usual. It should be twice as much because the giant mutation on it. Let me check. These are similar in size. Oh, wait, that's an. Oh, it's not changing the text based on it was giant. Inside of plot data handler, we need to. Sorry, not plot data handler. Plant handler. Inside of harvest plant, right here where it says mass, and we're passing through the mass. And we're doing harvest plant. We're passing through that mass. Let's see. Plant.mass. Initialize plant. When we set the mass, it is mass equals mass. Oh, we didn't multiply the mass. You know what? Whoops. We need to multiply plant scale first. So right here, I'm gonna delete that and put it underneath the size multi thing. We're gonna do the same in load plant. So delete the price and mass calculation thing and put it between these two. Okay, yeah, I'm gonna reset the data again because yeah, I don't know what's happening. Oh my goodness. Wow. There's a golden apple tree. That's cool. And it's giant. Jeez. Is that really only 3 times the size? It's crazy. Alright, so I need an apple. Either way. Oh, there, look, it says the right mass now. If you have any problems, you can join my Discord server, link in the description. Thanks for watching. I'm almost to 800 subscribers. I would really like to hit 1,000 by the end of June, if I can. So, as always, thank you very much for watching, and make sure to like the video and subscribe so you don't miss the next episode.